Okay, so now I'm gonna solve the problem 3 in the linear impulse practice problems. And we're talking about an object, any object that has a velocity of 1.4 meters per second in the positive side. Let's just start with a frame of reference here. Let's say that right is positive, and we have, let's say, object A, we have object B. So object A is going to the right, and object B right there is going to the left. Object A has a velocity of 1.4 meters per second and a mass of 0.3 kilos. Whereas object B has a velocity of minus 2.5 meters per second and a mass of 0.15 kilos. And we want to know what the velocity 2 after they collide will be. So remember, the momentum before is equals, for a collision, is the same as the momentum after the collision. The only thing is that before, that momentum is going to be the addition of each of these two objects separately, like added together. And then after that, they become a unit. So then over here, they're going to have the addition of their masses, but only one velocity. Okay, so if we expand this, we're going to have the momentum of A plus the momentum of B, and it's one here and one there because it's before the collision. Okay, so let's focus on this. And this one is going to be equal to the mass of A times the velocity 1 of A, again before they collide, plus the mass of B times the velocity 1 of B, right? If we put numbers to this, we're going to end up with 1.4 meters per second, that's positive, times 0.3 kilos, plus the mass of, oh well, sorry, that's that and that's that. Then we're going to have the mass, which is 0.15 times the velocity, which is minus 2.5 meters per second. And all of this is going to be equals to m1. So if we do the calculations, it's going to be 0.42 kilogram meter squared. This is positive. And then minus, because the momentum of this object that's traveling to the left, because it's going to the opposite direction of the positive, is going to be 0.38 kilograms per meters per second. And this will be equals to 0.04 kilograms meter per second. right? So we subtract this from that because this one is negative and this one is positive. Back to this formula here. Remember that the momentum that is generated by each of these objects separately before the collision is going to transfer after the collision. However, in the second part of the collision, because now they're going to be a unit, now we treat them as if they were together. So what are we going to do with their mass of the unit? Right. The mass of the unit is going to be equals to 0.3 plus 0.15 kilos. That comes to 45.45 kilos. And we already also have a value for M1. So what we're going to do is we're going to go M1 is going to be equals to the mass of the unit times the velocity of that unit, right? So this is going to be, oops, no. So we already did that. We already took into account the momentums of each of these objects, right? So we calculated momentum for A and momentum for B, and this is what we got. So momentum for A, momentum for B, and then we have M1 calculated, which involves the addition of 2. And now we're going to rearrange because what we want to know is what the velocity will be, right? We already found this. And all we got to do is go velocity 2 is going to be equals to M1. So the momentum for everything separately before the collision. And that's going to be divided by the mass of the unit. So we already calculated the mass of the unit, which is the addition of the two bodies. And then we have the momentum. So substituting numbers, we're going to have 0.04 kilogram meter squared. And then we're dividing that by the combined mass of the two. So 0.45 kilos. And we will end up with 0.09 meters per second. And that's your answer.